Hi, I'm Marie Blanchard from SolidWorks, and today we're going to talk about Computational Fluid Dynamics Tutorial, SolidWorks Flow Simulation Part 2. We provide instructors and students an introduction to flow analysis applications using SolidWorks. We also provide the Flow Simulation Tutorial and the Flow Simulation Technical Reference. Looking at how to solve engineering problems with SolidWorks Flow Simulation is an invaluable reference. In the Flow Simulation Instructor's Guide, we take a look at an exercise given to students. This project is called Project 1. In the Flow Simulation tab, you want to read from left to right, and the first place that I would suggest is the wizard. The wizard will walk you through the boundary conditions and the goals of your exercise. If you do not have flow simulation displayed, select on Tools, Add-ins, and check the SolidWorks Flow Simulation box. You will also see under Help, SolidWorks Simulation, Flow Simulation Online Tutorials. These two can provide examples. Let's go back to our question. Under Inlet Velocity, be certain to select the inside face. Right-click Select Other to make sure you have the inside face, whether you're dealing with a pipe or a channel. You can add additional boundary conditions. For example, here I right-clicked and used Select Other to get the inside face of the channel in static pressure conditions. For ideal wall, we want to look at all the walls that bind the fluid. So in this boundary are actually small faces that need to be selected. This is very important in SolidWorks when you have small radii or chamfer edges. It's probably a good idea to create a separate simplified configuration where chamfers and radii are suppressed, unless you're really looking at how that radius is going to affect flow. I would suppress it. In this large channel, it doesn't make sense to have small finite radii to add to your computational time or to add to your selection time. When you select your goals, you can have pressure, velocity. What are you actually looking for? Again, when selecting faces, make sure you select the face that is going to touch the fluid. In creating your equation, you want to watch out for parentheses, that you're calculating your equation goal correctly. In this case, I have inlet total pressure minus outlet total pressure. That quantity, that entire quantity, first must be evaluated before it is divided by the inlet dynamic pressure. In this case, you also want to be concerned with what is the dimensionality of the equation that you are calculating. In this case, my equation, the units all cancel out, so there is no units. It's a constant value. Select your variables right from the Feature Manager in Flow Simulation. That way you won't misspell them in the equation dialog. Right-click on your project and select on Run. Run will take a few minutes depending upon the complexity of your problem, your geometry, your inlet conditions, and your goals. Once the project is running, you will see a computation time and the type of equations or number of equations that are being calculated. Once complete, select on your goal graph. I have selected all of my goals to graph. Now return to the results area and let's take a look at the contours. You can select faces directly from within SolidWorks or from the Feature Manager. Control 1 is a shortcut to display the front view. Notice the contours. Let's also take a look at flow trajectories. Again, I will use the Feature Manager to select faces directly. All of these results have multiple options. Do you want to display vectors or change the color scale? When you animate a flow simulation, you must stop the animation before returning to SolidWorks. In Program Files, SolidWorks Corp, you will see your SolidWorks Flow Simulation folder. I recommend that you copy the entire folder of validation examples. These validation examples verify and validify SolidWorks compared to theoretical solutions. There is also another document that corresponds to these validation examples. That is located in the language section. So you want to select on SolidWorks Flow Simulation, Language, English, and then select on Docs. The technical reference document has two sections. Inside this document, you will see the physical capabilities of flow simulation and the ability to study a wide range of problems in fluid flow and heat transfer. Also, the governing differential equations, Navier-Stokes equations for lamina and turbulent flow, and how these equations apply to the fluid flow analysis that is used in SolidWorks. There's also a chapter for the validation examples that you just copied the folder over to your own desktop to review and to validate and verify the computational fluid dynamics solution with the theoretical solution. Looking at the validation example, flows in 2D channels with bilateral and unilateral sudden expansion, you can review flow velocity field in a unilateral expansion channel as compared to the computational fluid dynamics example you just did in SolidWorks. In addition to these documents is another document called Solving Engineering Problems, looking at different types of theoretical problems, advanced knowledge in mesh, humidity, cavitation, and steam. I recommend that for these problems that you have had or are taking a class in fluid mechanics, fluid dynamics, hydraulics, heat transfer, so you can see the correlation between what SolidWorks does in computational fluid dynamics and what you are learning in your theoretical based courses.